Hi everyone. So in this video, what we'll talk about is how a user actually interacts with Notional and actually executes lend-or-borrow trades. The way we do that from the website is through a method here called batch, balance, and trade action. And so what we'll do is walk through this function at a high level, and then we'll dive into sort of its components. So the first thing we'll look at is the balance action with trades struct, which is here. So this is defined for every currency that the user wants to interact with on Notional. So in Notional, we define currencies based on this numeric ID, and we do that just to sort of reduce the amount of storage space required to refer to a currency rather than store the entire sort of token address. Then we have a number of parameters that refer to the type of deposit action that a user might take. So in Notional, we allow users to deposit either C tokens or the underlying token. If you deposit the underlying token like DAI, it'll be wrapped to C DAI for you. And that's just a way to get more of a sort of one-click kind of experience. And then we have a number of fields here that define the type of withdraw action that the user might want to take if they are withdrawing. And we'll talk a little bit about what this might entail as we get there. And finally, there's an array of the trades that the user wants to make. And we'll talk about the different types of trades that a user could do through this batch action. But this is all to say that the this batch action approach is really just a way to improve the user experience, that the user can do a number of things in a single trade, such as deposit collateral and borrow, without having to submit multiple transactions. So we'll walk through this function at a high level, and then we'll dive into each one of its components. So the first thing here is we require that the account comes from the sender, or it's called from the address itself. Now this is a way for us to have separate contracts that authenticate maybe operators or other accounts for taking batch balance actions on behalf of users, but we'll talk about that in a separate video. The first thing we do before we do any sort of actions on an account is we check if the account needs to be settled, and we do so. So settlement is required in Notional, which is unique because of the fact that Fcash balances mature. So when Fcash balances mature, they're removed from a portfolio and they're applied to a cash balance. And we won't go into the settlement code in this video, but we will revisit it later. But this type of check is done in a lot of the user-facing code before we proceed. It's just easier to assume that all the assets in a portfolio have been properly settled before we try to do anything to it. So when we do these batch actions, we want to assume that that they're sorted. It just makes it a lot easier to sort of keep track of things when we kind of move on in the code. So the next thing we do is what we call pre-trade actions. So in pre-trade actions, we really do two things. One is we take any sort of settled amounts, cash balances that have been settled in this process, if they exist, and we sort of merge them into cash balances that have been loaded. So for example, if you are going to lend DAI, so say you've lent DAI, it's matured, and now you want to lend it again. So you're kind of like you're taking the kind of Fcash that's matured and you want to lend it to a further market. What we're going to do first before we enter the trades is we'll settle that Fcash to your cash balance. So now your cash balance says you have 105 DAI. And then what we'll do is, so then when we enter trading, you'll have that cash balance applied already, and then you can use it. So you can actually do this without having to deposit or withdraw any sort of cash. There's other, so in pre-trade actions, we also do deposits. We take care of deposits there. So if you are going to deposit, collateral or deposit, perhaps CDI for lending, for fixed rate lending, we'll process that there. And then if you've specified any sort of trades, then what we'll do is we will go ahead and execute those trades by calling this trading action library, and we'll take a look at that in a second. When the trading action returns, we'll check that, if you do owe cash after all the sort of net trades that you've done, that you have sufficient cash in your balance to actually do that, and then we'll net off that in your balances. And the last thing we do here is for a particular currency, we'll process any sort of withdrawals that the user might want to do. And before we exit here, what we'll do is we will update this account context object, which contains sort of a bunch of sort of metadata about a user's account. We'll update the portfolio, and we'll finalize any sort of settlement amounts that were not referred to in the loop above. So if you're just trading DAI and maybe you have a USDC balance that is settled, we'll finalize that here. And the last stage here is this finalize account context function. And so we set the account context to storage, and then we'll check if the account has debt. And this is a very important check. So for users that are just lending, they are never at risk of liquidation. And so, we don't need to check free collateral for them. Free collateral is a fairly expensive action, so we want to avoid it if possible. But if a user does have debt, if they have borrowed, we need to check that they have enough collateral to support that borrow, and we do that on every action. So free collateral is something we'll talk about in depth in a separate video, but just note that this flag is very important. If it's set improperly, an account will skip their free collateral check and will essentially be able to borrow for free. So we really need to be careful about this. Okay, so now we'll take a look at pre-trade actions and calculate withdrawal actions before we dive into the actual trading actions. So pre-trade actions here, what we do is we want to ensure that by the time we enter these trading actions, we have as much sort of net cash in the account as we can possibly have, so that we can execute these trades properly. So in trading actions, what we'll do first is we will load the balance state and apply these settled cash balances to the net cash amounts. So let's take a look at the balance state object here. Each balance state refers to a single currency. We'll have what's stored on chain. So we'll have the stored cash balance, stored end token balance, and a couple of other variables for calculating incentives. And then we'll have these 4 net cash amounts that sort of accrue throughout the transaction. And what that is used for is to ensure that we only do one ERC20 transfer, or we do the minimum number of actual ERC20 transfers that we need to throughout the transaction. And so as a transaction proceeds, what we'll do is accrue a net change to the balances, and then finalize them at the end. And so we can look at the balance handler function, which is inside internal here, and we can look at how we load the balance state. So the way we load the balance state is we get the storage manually through an sload call and unpack the 32-byte word into these different variables. And here we're using the same balance state object in memory for each pass through the batch action loop above here. So you can see that it's declared above, and then we're going to reuse this memory spot for each loop. So we're careful here to clear all the values every time load balance state is called. From there, what we'll do is we'll execute these deposit actions. So we'll take a look at the enum for deposit actions here. So we have a number of deposit actions that the user might take. So there's obviously none, and then the user may want to deposit asset cache, which in this case is C tokens. Now the code is structured that this asset cache is generic, so it does not have to be C tokens. It could be Y tokens or A tokens or what have you, or any sort of other interest-bearing token. Next, we can deposit underlying, so that will actually be like DAI tokens. If the user wanted to deposit underlying, Notional would transfer the DAI and then wrap it into C tokens before we completed this step. And then there are a number of deposit actions that have to do with N tokens. And so these are sort of really for convenience and for providing a good user experience. So if the user wants to deposit asset cache or underlying, what we'll do is we'll do that first, and then we will provide liquidity using that, what's been deposited into the N token. And we'll talk about the N token in a separate video, but here we're just demonstrating how a user might do that in a single transaction. Redeeming N tokens is here as well. So when you redeem N tokens, you convert an N token balance into an underlying cash balance, and then you can withdraw it. So and that burns the N tokens in the process. So that's similar to withdrawing your liquidity. We provide it as a deposit action type here because it generates a positive cash balance for the user, and they may want to use that to later either lend with it or do something else with it as a trade before they withdraw. And finally, there's a convert cash to N token. So you may have accrued a cash balance as a result of lending. So you have an F cash balance that has matured. So you'll have a positive F cash balance. Now we provide this as a convenience method to convert that cash into an N token if you don't want to lend. So when we execute deposit actions, we have a sort of an if-else block here, and depending on the type of deposit, we will execute one of these two functions in the balance handler. So let's take a look at that. So again, the goal here is to limit the number of actual ERC20 transfers that we do to hopefully just one during the transaction, but it may require multiple. When we deposit a C token, we can apply that, we can simply assume that that amount will be transferred later when we finalize and kind of exit. So we don't have to do any sort of transfer here. Now, if the token has a transfer fee or we want to force the transfer, we'll actually do the transfer at this stage. When doing underlying tokens, since we will end up doing a transfer and a mint action to generate C tokens, we'll do that here. So the token is first transferred to Notional, and then we'll mint with what's been transferred, and then credit the balance with that particular net cash change. So it will be a lot more gas efficient to deposit C tokens if you can, but as convenience, you can do it in the underlying. Once we've done these deposits, then we'll move on to executing N token actions. So These, again, are conveniences for the user. If the user wants to mint N tokens, we'll check that they have sufficient cash balance to actually do so, and net it off, and then mint tokens through this library function. And a similar process happens here, checking the N token balance, and then redeeming the N tokens back into cash and crediting the user's balance. We won't talk about these particular libraries in this video. They're N token mint and N token redeem, but we will discuss that in a subsequent video. Now, before we move on into the trading action, we'll just take a look at withdrawals, since we are talking about balances at this point. So when withdrawing balances, we allow the user to specify 3 options here. So one is to withdraw an amount in what we call internal precision, which is 8 decimal places. Now, C tokens are also in 8 decimal places, so for the most part, there's not going to be any sort of translation or necessary when you want to withdraw C tokens. But it's possible that we support withdrawing tokens of other decimal precisions. Now, Notional uses 8 decimal precision for all internal accounting, and so we'll sort of convert that into the external token precision when we do withdraw. But it's important to note that here, when you want to withdraw, you need to specify an 8 decimal precision. Similarly, when you deposit, you'll specify the sort of native token precision. So for DAI, you would specify it in 18 decimal places. We have 2 other options here. One is to withdraw entire cash balance. So this is useful when lending. So when lending, you specify the F cash balance that you want to lend, but the cash balance is sort of not totally deterministic. It'll vary just kind of based on the time and a number of other elements. So this flag is useful to sort of clear out the cash balance and ensure that you don't end up with some sort of like dust amount of cash sitting in Notional that's not being used efficiently. And the last thing is an option to redeem to underlying. So if the user wants DAI instead of CDAI, they can specify this to be true, and they'll get DAI back. So we'll unwrap it from the C token for them. So the initial part of this function is just calculating these net kind of withdraw amounts and assigning them to the right balance state variables. And then what we'll do is we'll call Finalize. So when we look at Finalize in the balance handler code, we're going to do a number of checks to make sure that balances don't go negative improperly. And then we'll finalize transfers here, which will actually action any sort of token transfers and things like that need to happen. Now, this is all handled in an object here called token handler, which has a number of sort of wrappers for handling redeeming, transferring ERC20 tokens. It checks return codes and things like that. We won't get into this in this video. Continuing on and Finalize, we do all the calculations to get the new kind of stored cash balance and stored N token balance here. Then what we'll do is we'll update the balance storage. So updating the balance storage happens here, and what that basically is just setting it via the store call. And then before we end here, we'll do a couple things. We will set an active currency on that account context. This is something we won't dive into in this video, but this is a way of tracking what currencies an account has balances in. And lastly, we'll take a look at this. So cash balances, so an account cannot withdraw a cash balance to a negative position. We check that here. However, an account may have a negative cash balance if they've borrowed Fcash, so they have a negative Fcash balance in the future, and it has come due, so it's matured. And once that happens, the stored cash balance will become negative, and we'll set a flag saying that the account has cash debt. We'll get more into this process and what happens here in a subsequent video when we talk about settlement. So now we've kind of covered what happens in pre-trade and these finalize actions. We'll take a look at trading. So you'll notice that there's two methods here. There's execute trades bitmap batch and execute trades array batch. So within Notional, we have two portfolio types that hold Fcash. One is a bitmap type, one is an array type. So we won't talk about the bitmap type in this video. Now the array type is what most users will be doing, so we'll take a look at that. But the way trading actually occurs for these two is very similar. So what'll happen here is indicative of how trading occurs for users, for all users. So when we look at execute trades array batch, we see that trades is an array of 32 bytes, kind of like tightly packed 32 byte objects. So let's take a look at the schema for that. So we have this enum, which is called trade action type. This is the first byte of this 32 byte kind of tightly packed object. The enum will represent the different trade types that we have. So lend, borrow, add, and remove liquidity, which we've sort of discussed in the previous video, what happens there. And then we have these two other trade types that are a little bit more unique, and we'll talk about in a separate video about settlement. So we won't mention these here. The user will also need to specify a market index, which is sort of the reference for the Fcash market, and the kind of requisite amount that they're willing to trade. Note that when you're borrowing, you will incur a negative Fcash balance, but here the user specifies in a positive amount. And finally, these min implied and max implied rates are used as sort of ways to specify slippage. So the transaction will revert and the user will not borrow if the interest rate is above a certain value. So this is just a way to protect against front running or any sort of slippage. Okay, so now we'll look at how we execute the trades that are specified by the user. So when we look at this function inside the loop, we'll process each of the trades sequentially. And if the trades are add or remove liquidity, we'll execute it specially here. So the reason why these are executed specially here is that the bitmap portfolio doesn't hold liquidity tokens, so we split it up this way. So looking at executing liquidity trades, the function here is fairly simple. We'll load the market state, the market object from storage based on the market index, and then either add liquidity or remove liquidity as the user has specified. We will check that the rates after the trade don't fail our slippage checks, and then we will add the Fcash assets or add the liquidity tokens to the user's portfolio. Note that in this case, when we remove liquidity, we're going to add a negative amount of tokens to the portfolio. That's here, and that will sort of net off whatever token balance that they have. We do ensure that the token balance does not go negative inside this function call. When we look at lend and borrow trades, it's largely similar. We'll load the market. We will calculate the trade here. If the trade type is borrow, we'll switch the Fcash amount to negative to represent the account taking on a negative Fcash amount. And if the cash amount is returned as 0, what that signifies is there wasn't enough liquidity to trade. And then we'll also check the slippage limits here. In both of these methods, what we'll do is we'll set the market storage. So we'll take a quick look at that inside market.sol. In Notional, generally, when we set storage, we'll do something like this. We'll check that the in-memory object does not go out of bounds of the size of the storage slot that we're taking up. So 80 bytes here, or 80 bits here. And then we'll pack that into a 32 byte storage word and then call store here. Now in set market storage, we're using 2 slots here, so important to note that the total liquidity goes in a different storage slot than the rest of the variables. And also want to point out that the oracle rate is reset to the previous value if no trade has occurred. So we'll get into the oracle rate separately when we talk about the valuation curve, but I did want to point out that this set market storage method has a little bit more logic in it than sort of the balance storage method.